Hello everyone, nice to meet you again. In this video I will show you my new project, which is connecting the quadcopter, this big huge quadcopter right here, with you can say an ultrasonic sensing project. Well, I call it an obstacle detection project, which detects obstacles. This device detects obstacles and further can give information to the quadcopter controller to avoid these obstacles. Anyways, so what I did exactly in this device, as you can see right here, I attached an ultrasonic sensor with a servo right here, and you need also what do you call this, an LCD crystal screen, also connected here with an Arduino. And of course this is handmade. Of course I modified this at home. I made this box right here which contains all the wiring inside, also contains a breadboard for all the connections with the Arduino, and also with the server on this crystal screen right here. If you need more detailed information about how I made this, I can well, depending on the requests on my page, I will disassemble this and show you how I made it bit by bit. Anyways, so that is not all. This is not all. Let me explain a bit what you see right here in the screen. I made this program to display the obstacle angle, or the angle direction, or you can say the direction of the obstacle, and also the distance. So these two information right here are really important in order to feedback the controller, and in order for it to know what to do exactly and which direction it needs to respond to. So the other part of my project, this is only half of my project. The other part is connecting, is receiving and plotting these information right here on my computer via serial, as you can see here. So this is a software I made. Of course you got my logo right here, which is Quadzinator, and my name here, and the name of the project, which is obstacle detection. So this works almost like a radar. I made it look like a radar because it works almost like it, just with ultrasonic sensors, of course. Alright, so how does this work? This graph right here shows the 180 degrees of this half circle, and I separated this half circle into eight sub-circles, or whatever you call it. And why did I do this? I did this for us to easily detect where the obstacle is and map it on this map. So it starts from here. This is 0 angle, then 25, and then you go 22.5, then 45, then 62, I think, 0.5, and then 90, and then you go on until you reach 180. Here, this program shows you and maps the obstacle in front of the quadcopter. I'll show you how it works from the beginning. It will be easier. Okay, so these are the two programs I made. The first one right here is a program. These are the instructions I wrote, I modified in order to make the Arduino operate as it is right now with the LCD. I inputted the LCD and the servo, and also the ultrasonic sensors, and I made the instructions what to do exactly. And this one on the left right here, this is a specific instruction in order to draw this program and make it map the obstacles correspondingly to the, as you can see here, the angle and the distance and the current servo angle. Yeah, it's the same thing. So if you can see here, let's see the position of the sonar right here. Alright, okay, ultrasonic is sonar, by the way. So let me start the program and then see what happens from start. As you can see, there is no obstacles right now. Let's see if I put my hand here. Let's see what happens. You can see my hand is 10 centimeters away from the sonar, and as you can see here, this is the graph of my hand. Of course, I rotated myself with the ultrasonic sensor. Okay, now it's like you can say 180 degrees. Let's put my hand over there and see what happens. Okay, let's go like this. Look, it graphed here on the same angle. Let me go a bit further. Look, you can see here what happens. Anyways, I hope you like this the project. I still need to add some instructions in order for the quadcopter to take some actions due to the information it will get from the ultrasonic sensor, and also the angle, of course, corresponding to the angle. The limitations of this project, for now I use this type of sensor. It is not that efficient. It is efficient until 4 meters maximum, of course. I kind of limited my program to 3 meters radius around the quadcopter, because that's the effective range of this ultrasonic sensor. It's just a cheap $2 sensor, but it works perfectly, to be honest. You can easily change this sensor with a laser, a LiDAR, anything you want. Actually, even a better ultrasonic sensor. But it works perfectly. I will see, and I will be waiting to see how it works and functions in the air. If you need the instructions, please let me know. If you need the instructions of how I made this program, okay, it's copyright, as you can see, it's Quadzinator. Alright, if you need the program, please subscribe and then request it on my YouTube channel. I will be delightful to share this, even though that it cost me a lot of time working on it. Anyways, thank you guys, hope you enjoyed this, and subscribe, Quadzinator.